Alright, so in simplifying radicals with a negative underneath, you simplify excuse me, as if there was no negative. The negative is just, we just put the I at the end. So when I deal with this, I'm not dealing with the negative. It's 2 and 24. It's 2 and 12. It's 2 and 6, and it's 2 and 3. It's a prime factorization. Pair of 2s. Pair of 2s, and there's a 3 that's prime left over. So it becomes 2 times 2, and the 3 goes in the radical. And my answer is 4I root 3. With 160, 2 and 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. Pair of 2s, pair of 2s. There's a 2 left over and a 5 left over. I always like to box the prime numbers that are left over. This becomes 2 times 2 and 2 times 5 in the radical. Whenever you have multiple pairs or multiple prime numbers left over, you always multiply them. This becomes 4I root 10. If it were root 160, it'd be 4 root 10. Since it's negative root negative 160, it's 4I root 10. That's the only difference. Adding and subtracting complex numbers, we're just combining like terms. That's it. 6 and negative 3 is 3. 3I and 7I is 10I. When you subtract, my advice is to write the problem over again with the negative distributed. Negative 5 and 6 is 1. Negative 8 and negative 11 is negative 19. Those are what I would argue are gifts on the test. When you multiply, we're foiling. 4 times 3 is 12. 4 times negative 8I is negative 32I. 7I times 3 is 21I. 7I times negative 8I is negative 56I squared. We have to know I equals the square root of negative 1, and more importantly, that I squared equals negative 1. So this I squared is technically, or not technically, is a negative 1. Basically, it changes the sign of the back number. 56 and 12 is 68, because it turns as negative 56 positive. Negative 32 and 21, minus 11I. Three times negative 5 is negative 15. 3 times 2I is 6I. 4I times negative 5 is negative 20I. 4I times 2I is 8I squared. And that 8I squared becomes a negative or positive 8 times negative 1. It turns it into a negative 8. Negative 8 and negative 15 is negative 23. 6I and negative 20 is minus 14I. Completing the square, the first thing that has to happen is we have to have a 1 in front of x squared. So if that happens, we can go right to our next step, which is moving the constant to the other side. So x squared plus 8x equals negative 10. And then the trick is taking half this middle term, which is 4, and squaring it. And basically that creates a binomial squared, very similar earlier in the study guide. Okay, you can't complete the square without creating a binomial squared. So by taking half of 8 and squaring it, half of 8 being 4, 4 squared is 16, I create my binomial squared. When I factor that, it's x plus 4 squared. It's always half the middle term. And negative 10 plus 16 is 6. And now I'm doing what I did earlier. I take the square root of the binomial squared. When you take the square root, the exponent goes. You cannot simplify root 6. So you just leave it as plus or minus root 6. And we finish the problem by subtracting the 4 over. Negative 4 plus or minus root 6. That's my answer. Our first step when there's not a 1 in front of our x squared is to take whatever number's in front of x squared and divide every term by it. We've got to get a 1 in front of x squared. So this turns into x squared minus 6x minus 11. From there, we're doing what we literally did on the last problem. Everything else is the same. But if you don't have a 1 in front of x squared, you cannot complete the square. So we've got to get to that 1 by dividing everything by the coefficient of x squared. Now, I'm going to add 11 on both sides. Half of negative 6 is negative 3. Negative 3 squared is 9. This factors x minus 3 squared equals 20. And now I'm taking the square root of both sides. Oops. Let's not get ahead of ourselves here. Square root of x minus 3 squared equals the square root of 20. If you can simplify that radical, you must do so. 20 can be simplified. So I have my x minus 3 here, but 20 is 2 and 10, 2 and 5. So that becomes plus or minus 2 root 5. And then we finish by adding 3 to both sides. You always write your real number first, your rational number. I shouldn't say your real number first. You always write your rational number first and your real number second. Okay. So before we do completing the square, I need to make sure my signs are right. Now this might seem a little overkill here, but I want to set it up this way every single time. I'm going to subtract everything over. And I know in a second I'm bringing the 30 right back over. I don't care. I don't want to do completing the square until everything's equal to 0. And now I divide everything by 2. Because I can't complete the square unless we're equal to 0 and we have a 1 in front of our x squared. So now I've set this problem where all the signs are right and I can complete the square. Now, first part is simple. We add 15 to both sides. So I'm going to... Alright, so we're going to take half of this middle term, which is negative 5 halves, and square it. Negative 5 halves is 25 over 4. So we add 25 over 4 on one side, and I'm going to make this 15 over 1 plus 25 over 4. Okay? And now we're going to multiply 4 over 4 to 15 over 1, and that leaves me with a common denominator of 60 over 4, which equals 15. It doesn't change the value. When I factor, it's always half the middle term. And then this is 85 over 4. And now we're going to do the same process. I'm going to square root x minus 5 halves, square root of 85 over 4. When you take the square root of things, obviously this is x minus 5 halves. Here, it becomes the square root of 85 over the square root of 4. When you take the square root of a fraction, you split the radical up. Square root of 85 over the square root of 4. I can't break down 85. The only prime number that goes in 85 is 5, and it goes in 17 times. There's nothing that doubles up there. But what's nice here is this. The square root of 4 is 2. So this becomes plus or minus root 85 over 2. And then we finish the problem. 5 halves plus or minus root 85 over 2. And there's our answer. And that's how you deal with a fraction in your completing the square. I didn't do anything differently than I did on all the other previous problems. But unfortunately, what happens with a lot of us is we see a fraction and we freak out and we do whatever. Do not guess, do not do whatever. You've got to make sure you're following the set process. Are there any questions, concerns, or issues? And that's your review. All right. Do you want to start something in the last 10 minutes of class? So let me just record this. Because it's something you should have already seen anyway.